Hello, everyone, and welcome back to the React series. I'm RJ. I should probably get better audio equipment, Calamito. And did I just tell everybody my last name? Oh, well, it was in the last video. Forget it. Anyway, I did promise we would start with Intro to Astronomy. I'm recording this on July 5th. Yeah, because yesterday it was July 4th, and Geography Now posted the USA video. America. And so I didn't get to record this yesterday. I'm also testing out the virtual background since it fits today's subject matter. And it is hot as shit in here today. So we're going to try something new. Really should bore that out. Anyway, this is Crash Course's Intro to Astronomy. And so, look, Crash Course is one of my personal favorite YouTube channels. That's not going to be much of a surprise as we keep going on with this. I was in middle and high school when this channel really started taking off. I remember the World History series was, I believe, I was in seventh grade. Yeah, 2012. So, yeah, like when John Green made the World History series, I was in seventh grade. By the time this series comes out, and I believe 2015, yes, yeah, just wanted to make sure. By the time this came out in 2015, I was already a high school sophomore. So, yes, sophomore. So, this was a big part of like my middle and my high school years, so those golden years, so to speak. And I promise if this background does not look normal and it's already starting to give me a few issues, I'll replace it in the next video. And like I said in the intro, I'll probably eventually get better audio recording equipment. But astronomy is my favorite of the Crash Course series. And as a guy who's a student of various different disciplines, right now it's computer engineering and computer science, I've always been into space, right? I've always been a space guy. I've always been a sciencey guy. As I mentioned in yesterday's video, I grew up in New York. I grew up in basically in Jersey. And so the Liberty Science Center was a big part of my childhood. If there's one thing that you will never find in shortage in New York, it's museums. You have MoMA, which is art. I know it's not science, but whatever. Museum of Natural History, Museum of Jewish Heritage, Museum of the Native American, I believe. I'm gonna get roasted for not knowing that, especially because it's right off the Staten Island ferry going into Manhattan. I'm gonna get roasted on here for not knowing that. But anyway, let's cut the intro out because I feel like I've already been talking too long, and let's dive into what's honestly my favorite school subject.
Hello and welcome to Crash Course Astronomy. I'm your host, Phil Plate, and I'll be taking you on a guided tour of the entire universe. You might want to pack a lunch. Over the course of this series, we'll explore planets, stars, black holes, galaxies, subatomic particles, and even the eventual fate of the universe itself. But before we step into space, let's take a step back. I want to talk to you about science. There are lots of definitions of science, but I'll say that it's a body of knowledge and a method of how we learn that knowledge. Science tells us that stuff we think we know may not be perfectly known. It may be partly or entirely wrong. We need to watch the universe, see how it behaves, make guesses about why it's doing what it's doing, and then try to think of ways to support or disprove those ideas.
That's the basic scientific method: observation, no, hypothesis, observation, conclusion. I know I'm skipping a bunch of steps in that, but that's the basic scientific method. We need to know. Scientists, we love to be right, but we also love to be wrong in the sense that if we're wrong, we want to know if we're right. It's one of those things where knowledge is an evolving process. And so I'm glad he points this out. This is all science. It's not just astronomy. It's not just astrophysics. When we need to have claims, observable claims, claims, observations to back up those claims, and then justifications based on those observations, right? Those observations either prove or disprove a hypothesis, right?
That last part is important. Science must be, above all else, honest.
I said I wouldn't make this a political commentary channel. We're not going to. But there's a few things we could talk about that.
We really want to get to the bottom.
But no, he's right, right? Like, I don't want to like discredit that. He's right. We have to sort of be honest. Right? We have to be truthful to ourselves. We have to, like, if Pluto was a planet, right? We'd be lying because it doesn't actually meet our definitions of a planet. You hear that, Pluto? I'm joking. But
other things. Understanding that our understanding might be wrong is essential, and trying to figure out the ways we may be mistaken is the only way that science can help us find our way to the truth, or at least the nearest approximation to it. Science learns. We meander a bit as we use it, but in the long run, we get closer and closer to understanding reality, and that is the strength of science. And it's all around us. Whether you know it or not, you're soaking in science. You have mass. Mitochondria in your cells are generating energy. Presumably, you're breathing oxygen. But astronomy is different. It's still science, of course, but astronomy puts you in your place. Because of astronomy, I know we're standing on a sphere of mostly molten rock and metal 13,000 kilometers across, with a fuzzy atmosphere about 100 kilometers high, surrounded by a magnetic field that protects us from the onslaught of subatomic particles from the sun 150 million kilometers away, which is also flooding space.
Which is interesting because what a lot of people don't realize is just how devastating a solar flare would be to our planet if we didn't have that magnetic field. And there's observations to suggest that that field is waning. I wouldn't worry about a solar blackout just yet.
With light that reaches across space to illuminate the planets, asteroids, dust, and comets, racing out past the Kuiper Belt, through the Oort cloud, into interstellar space, past the nearest stars, which orbit along with gas clouds and dust lanes in a gigantic spiral galaxy we call the Milky Way, that has a supermassive black hole in its center and is surrounded by 150 globular clusters and a halo of dark matter and dwarf galaxies, some of which it's eating, all of which can be seen by other galaxies in our local group like Andromeda and Triangulum. And our group is on the outskirts of the Virgo galaxy cluster, which is part of the Virgo supercluster, which is just one of many other gigantic structures that stretch most of the way across the visible universe, which is 90 billion light years across and expanding every day, even faster today than yesterday, due to mysterious dark energy. And even all that might be part of an...
We're going to talk about this because this comes up in a later episode of this series, as you would expect. But for those of you who don't know, the universe itself is actually expanding, right? Which, come to think of it, seems to defy all, at least, visible physical expectations. We'll talk about that later, though.
An infinitely larger multiverse that extends forever, both in time and space. See, astronomy puts you in your place. Exactly is astronomy. This isn't necessarily an obvious thing to ask. When I was a kid, it was easy. Astronomy is the study of things in the sky, the sun, moon, stars, galaxies, and stuff like that. But it's not so easy to pigeonhole these days. Take, for example, Mars. When I haul my scope out to the end of my driveway and look at Mars, that's astronomy, right? Of course. But what about the rovers there? Those machines aren't doing astronomy, surely. They're doing chemistry, geology, hydrology, petrology, everything but astronomy. So nowadays, what's this?
It's kind of like how history isn't just history, it's economics, it's political science, it's philosophy, arguably. Right? It's the same concept here. Rovers are machines built usually by NASA, not always, but to collect data, basically, because, we can't get to Mars yet for obvious reasons.
Astronomy. I'd say it's still studying stuff in the sky, but it's branched out quite a bit from there. Borders between it and other fields of science are fuzzy, a theme I'll be hitting on several times over this series. Humans might like firm, delineated boundaries between things, but nature isn't so picky. And that brings us to our first edition of Focus On. This week's topic, Astronomers. Who are we? What do we do? I used to look through telescopes for a living, or at least study the data that came from detectors strapped onto them. But now I talk and write and make videos about astronomy and relegate my viewing to my personal backyard telescope. But I still consider myself an astronomer. So that should give you an idea that there's a lot of wiggle room in the profession. In fact, when I worked on Hubble Space Telescope, I was actually hired as a programmer. I coded in the language used by the folks helping to build and calibrate a camera that was due to launch into space and be installed on Hubble by an astronaut. Once the data from that camera are taken and analyzed, you have to know what to do with them. Do the observations fit the physical model of how stars blow up, or how galaxies form, or the way gas flows through space? Well, you better know your math and physics, because that's how we test our hypotheses. And someone who does that is generally called an astrophysicist. Of course,
everything from the conservation of angular momentum to gravity, basically everything in your basic physics class, like your physics 1 class, is going to come up in astronomy, right? The derivatives and the integrals that we use to determine the slope of a curve or the area underneath the curve in calculus is going to be in astronomy. And a bit of a spoiler alert for those of you who have never taken either physics, calculus, or astronomy. This is the reason, like when you get to college, usually to take physics, you also have to take physics. To take physics, you also have to take calculus, right? Usually calculus 2 or 1, depending on your institution. I know it's kind of stupid. But basically, once you get to integral calculus, right? That's when you get to start taking physics, and this is one practical application of that. I also want to point out that I'm glad he talks about what's an astronomer, because another thing you'll notice is that many universities don't really have astronomy majors. Don't get me wrong, they exist, and if you look for it hard enough, you'll find them. But they're usually physics and astronomy departments, or it's aerospace engineering, which is just as much about planes as it is as it is about shuttles, for instance. So again, there's a lot of wiggle room in what we consider an astronomer. It could go from computer scientists to engineers to aerospace engineers to writers and bloggers, and I think he mentions artists
telescopes
later.
and detectors don't create themselves.
Just 2 things. One, I've seen virtually all of these videos already, so that might come off as why I know what he's going to talk about. 2, I have a bit of a chipped tooth, and that's why you see me like over here. I have a chipped tooth that I have to go get fixed on Friday. That's why. I apologize for that.
We need engineers to design and build them, and technicians to use them. Most astronomers don't actually use the telescopes themselves anymore. Someone who's trained in their specific use does that for them. Some of those instruments go into space, and some go to other worlds like the moon and Mars.
One more thing I should point out. Generally, agencies like NASA, SpaceX, Northrop Grumman, Raytheon, Raytheon, maybe not Raytheon. So like industries that Boeing, that delve into aeronautics and aerospace, and obviously people that go into space, and then people that build the rockets and the telescopes and the rovers that also go into space. Usually you'll need a STEM degree, right? Like in that sense, you'll need some type of STEM degree, math, physics, computer science, etc. Right?
We need astronomers and engineers and software programmers who can build those too. And then at the end of all this, we need people to tell you all about it. Teachers, professors, writers, video makers, even artists. So I'll tell you what, if you have an interest in the universe, if you love to look up at the stars, if you crave to understand what's going on literally over your head, who am I to say you're not an astronomer? However you define astronomy, humans have been looking up at the sky for as long as we've been humans. Certainly, ancient people noticed the big glowy ball in the sky and how it lit everything up while it was up and how it got dark when it was gone. The other fainter glowy thing tried, but wasn't quite as good at lighting up the night. They probably took that sort of thing pretty seriously. They probably also noticed that when certain stars appeared in the sky, the weather started getting warmer and the days longer. And when other stars were seen, the weather would get colder, daytime shortened. Workmen settled down, discovered agriculture, and started farming. Noticing those patterns in the sky would have had an even greater impact. It told them when to plant seeds and when to harvest. The cycles in the sky became pretty important. So important that it wasn't hard to imagine gods up there, looking down on us weak, ridiculous humans, interfering with our lives. Surely, if the stars tell us when to plant and control the weather, seasons, and the length of the day, they control our lives too. And astrology. Astrology literally means study of the stars. As word, it's been used before science became a formal method of studying nature. It irks me a bit since it got the good name and now we're stuck with astronomy, which means the law or culture of the stars.
And basically it should be the other way around, especially given what astrology basically is now, where it's like, hey, this is what your horoscope says. And hot take, we're gonna go with the hot take right now. 6 minutes and 42 seconds in. I've never understood astrology. Like, what's the point if you're dating a Libra, a Sagittarius? Like, what the hell is the point? I swear astrology is its own placebo effect in that, like, people believe it and then it becomes true in that sense.
And that's not really what we do. But what the heck? Words change meaning over time, and now it's pretty well understood that astronomy is science and astrology isn't.
Go ask most members of Gen Z, and they'll probably tell you it's the opposite way. Oh, I'm going to hell for that one.
Millennia ago, astrology was as close to science as you got. It had some of the flavors of science. Astrologers observed the skies, made predictions about how it would affect people, and then those people would provide evidence for it by swearing up and down it worked. The thing is, it really didn't. The fault of astrology lies in ourselves and not our stars. People tend to remember the hits and forget the misses when predictions are made, which is why they sometimes sit in casinos pumping nickels into machines that are proven to be nothing more than a method for reducing the number of nickels you have. But
that's a video I'm gonna eventually do, which is why casino machines were designed, how casinos are designed. I think it's a SciShow Psych video, correct me if I'm wrong. About they did a video on this about why like casinos are designed the way they are. And spoiler, this, again, not to get into politics too much, this melds into social media a lot. This is a bit of a side tangent, but also this is a perfect picture to spin. This is literally a perfect wallpaper. Like, I should just screenshot that picture right now and just have that picture look at me every day.
Astrology led people to really study the sky and find the patterns there, which led to a more rigorous understanding of how things really worked in the heavenly vault. It wasn't overnight, of course. This took centuries. Before the invention of the telescope, keen observers built all sorts of odd and wonderful devices to measure the heavens. And in fact, it was before the telescope was first turned to the sky that a huge revolution in astronomy took place. It is patently obvious that the ground you stand on is fixed, rooted, if you will, and the skies turn above us. The sun rises, the sun sets. The moon rises and sets. The stars themselves wheel around the sky at night. Clearly, the Earth is motionless, and the sky is what is actually moving. In fact, if you think about it, geocentrism makes perfect sense. That all the objects.
I mean, yeah, if you basically don't, like, if you're a pre-telescopic society, like, it's very easy to believe in geocentrism, right? Like, when you go outside, you stare up, the whole sky seems like it's moving. It's not us that feels like we're moving. This would obviously get debunked by Nicholas Copernicus, and we would get what we now have, heliocentrism, which means sun-centered.
In the sky revolve about the Earth and are fixed to a series of nested spheres, some of which are transparent, maybe made of crystal, which spin once per day. Stars may just be holes in otherwise opaque spheres, letting sunlight through. Sounds silly to you, doesn't it? Well, here's the thing. If you don't have today's modern understanding of how the cosmos works, this whole multiple shells of things in the sky thing actually does make sense. It explains a lot of what's going on over your head. And if it was good enough for Plato, Aristotle, and Ptolemy, then by God, it was good enough for you. And speaking of which, it was endorsed by the major religions of the time. So maybe it's better if you just nod and agree and don't think about it too hard. But a few centuries ago, things changed. Although he wasn't the first, the Polish mathematician and astronomer Copernicus came up with the idea that the sun was the center of the solar system, not the Earth. His idea had problems, which we'll get to in a later episode, but it did an incrementally better job than geocentrism. And then along came Tycho Brahe and Johannes Kepler, modified that system, making it even better. Then Isaac Newton, oh Newton, he invented calculus, partly to help him understand the way objects moved in space. Over time, our math got better, our physics got better, and our understanding grew. Applied math was a revolution in astronomy, and then the use of telescopes was. Galileo didn't invent the telescope, by the way, but made them better. Newton invented a new kind that was even better than that, and we've run with the idea from there. Then, about a century ago, came another revolution: photography. We could capture much fainter objects on glass plates sprayed with light-sensitive chemicals, which revealed stars otherwise invisible to us, details in galaxies, beautiful clouds of gas and dust in space. And then, in the latter half of the last century, digital detectors were invented, which were even more sensitive than film. We could use computers to directly analyze observations, and our knowledge leaped again. When these were coupled with telescopes sent into orbit around the Earth, where our roiling and boiling atmosphere doesn't blur out observations, we began yet another revolution. And where are we now? We've come such a long way. What questions can we routinely ask that our ancestors would not have dared? What statements made with a pretty good degree of certainty? Think on this. The lights in the sky are stars. There are other worlds. We take the idea of looking for life on alien planets seriously and spend billions of dollars doing it. Our galaxy is 100 billion others. We can only directly see 4% of the universe. Stars explode. And when they do, they create the stuff of life. The iron in our blood, the calcium in our bones, the phosphorus that is the backbone of our DNA. The most common kind of star in the universe is so faint you can't even see it without a telescope. Our solar system is filled to overflowing with worlds more bizarre than we could have dreamed. Nature has more imagination than we do. It comes up with some nutty stuff. We're clever too, we big brained apes. We've learned a lot, but there's still a long way to go. So with that, I think we're ready. Let's explore the universe. Today, you learned what astronomy is, and that astronomers aren't just people who operate telescopes, but include mathematicians, engineers, technicians, programmers, and even artists. We also wrapped up with a quick history of the origins and development of astronomy, from ancient observers to the Hubble Space Telescope. Crash Course is produced in.
Okay, and so I think that's a pretty good place to sort of cut off the intro. So, yeah, I didn't really say that much this episode. I like to talk more when we get into sort of the depth. I think next episode is naked eye observations, so we'll talk about that. Yeah, I'm sorry. I wish I had more to say. It's way too hot in here, honestly. Like, comment, subscribe, tell me I need a better audio equipment if you feel like it. Tell me I need a haircut because I probably do. I also apologize. Like I said, I think I said this in one point in the video. I have a bit of a chipped tooth. My teeth are bothering me a little bit. So I'm going to go get that checked out on Friday. So there might or might not be a video Friday, depending on how I feel, depending on what happens. Maybe it's just a chipped tooth. Maybe it's filling. Who knows? Hockey guy. But so, yeah, I've been through it all. But anyway, yeah, I hope you like this video, and we're gonna talk about naked eye observations tomorrow. I believe. Yeah. Okay. So see you guys next time. Bye. Wait.